Hi everyone. Okay, so this is the very first lesson, Monday lesson, honors pre-calculus. Chapter 1.1, functions. Key concept, real numbers. So if you look at it, there's a number. Very inside the number, we label that as natural numbers. Natural numbers are numbers 1, 2, 3, 4, no zero, no decimal. The outside of natural number, we call that as a whole numbers. Everything in natural number plus zero is a whole numbers. Integers outside, integer means plus minus, no decimal. So include every whole numbers, also minus side. Okay, outside of that would be rational numbers. So rational numbers include all these three: integer, whole number, natural number. So rational numbers are numbers pretty much any number you can express as a fraction. So when you express as a fraction, the numerator denominator has to be expressed in integers. So integer over integer, you can express that way, then that's rational numbers. If you cannot express as an integer over integer, then you will be considered irrational numbers. Irrational number will have non-terminating, non-repeating decimal. If you look at rational, some of the fraction will be non-terminating, but it repeats. So that will be rational. If it doesn't repeat, irrational numbers. So most irrational number you can think of will be root with no perfect square in it. Like square root of 3 is going to be irrational numbers. Okay, example 1. Describe Describe 2, 3, 4, 5, 6, 7 using set builder notation. Set notation. So this is the answer. So set notation is right here. And you say x bar, x such that, what kind of x is that? Between 2 and 7. And also say x is element of n. N was what? Natural number. So you can say between 2 and 7, but no decimal, basically. This is how you use the set notation. Describe x is greater than minus 17 using set notation. So how do we express that? Set notation here first. You say x bar, which is x such that x is greater than minus 17. I don't think this is necessary. You don't have to say that. As long as you say x is greater than minus 17, then we are assuming that's a real number. Okay, write minus 2 less than equal to x less than equal to 12 using interval notation. Okay, so interval notation. I'm not sure if you're familiar with it from previous classes. In case you haven't forgotten, here I can go over one more time. So if you express on a number line, minus 2, 12, and as you can see, I made a solid dots. It's between minus 2 and 12. So x is greater than equal to minus 2, less than equal to 12. So you can just write as minus 2 to 12, minus 2 to 12. And if you have a solid dot bracket, solid dot bracket. So that's interval notation. If this was not solid dot, let's say solid dot to empty dot, for example, minus 2 to 12. What if this was minus 2, 12 without equality here? Then your set notation would be, not set notation, the interval notation would be minus 2, 12, bracket, parenthesis. So parenthesis is doesn't have an equal sign. Okay, write this x is greater than minus 4 using interval notation. So some of you might be able to write this directly from here. X is greater than minus 4. Just be careful how that reflected on the number line, if that's not easy for you. X is greater than minus 4. Don't get confused. Greater than minus 4. You gotta go to the right. So how do you express this using interval notation? This is the smallest possible. So you say minus 4, comma, what's the biggest possible? There's no end, meaning it's infinity, positive infinity. Infinity, whether it's positive or negative, always go with the parentheses. Infinity, always go with the parentheses. You will never go with the bracket. And minus 4 is empty dot here, so you will have to do parentheses. Okay. Write x is less than 3 or x is greater than equal to 54 using interval notation. So try to write this. X is less than 3. So less than 3, think about it. 3 here, less than 3, you gotta go to the left. So when you try to express in interval notation, what's the smallest can go? Smallest can go forever to the left, which is minus infinity, comma. What's the biggest can go? 3. Minus infinity, always go with the parentheses. 3 is what? Doesn't have equal sign, empty dot, so you have to do parentheses. So that's this portion. X is greater than equal to 54. Greater than equal to 54. 54 is here. Greater than equal to, you know you have to go to the right. Greater, smaller. X is greater than equal to 54. So what's the smallest number here possible is 54. What's the biggest you can go is infinity, positive infinity. Always parentheses with infinity. 54 is solid dot. So you gotta do bracket. Okay, or means you take everything. Or means you take this or you take this. Anyone satisfied is okay. So or means union. If they did and, there will be intersection. Intersection means you have to find a duplicate. Where do they overlap each other? You're only taking that overlapping part. So for example, if I say x is less than 3 and x is greater than equal to 0, for example, this is a separate question, by the way. So you can say x is less than 3 and x is greater than equal to 0. So 0 is somewhere over here. It's going this way. So it's going here, it's going here. And the relationship, you have to find intersection. Intersection happens right here. Greater than equal to 0, less than 3. So intersection will be greater than equal to 0, less than 3. And as an interval notation, it will be 0, 3, parenthesis, bracket. Okay, concept of function review. Function, a function f from set A to set B is a relation that assigns to each element in X in set A exactly one element Y in set B. Okay, I don't know if you caught this. Each element in set A exactly one element in set B. What are they talking about? One input only goes to exactly one output. That's what it means. One input can only go to one output. What does that mean? If you ever see split, like let's say 1, 2, 3, let's say A, B, C. If you see any input producing more than one output, sometimes outcome is A, sometimes outcome is B, that's not a function. That's not a function. So if one input splits to more than one output, that's the part you say, okay, it's not a function anymore. Vertical line test, if your relationship is presented on a graph, you can use a vertical line test. So put vertical line anywhere you like. If that vertical line passes graph more than once anywhere, that's not a function. So at most one point, anywhere you put vertical line, it can pass graph only one point or no point at all. If it passes more than one point, that's not a function. It fails the vertical line test. Okay, determine whether the table represents y as a function of x. So what do we look for here? We look for the input value, which is x value. Aha, do you see x is input as a 1 twice here? What's output here? 1 and minus 1. The same input of 1 is producing different outputs. Sometimes it's minus 1, sometimes it's 1. Right then, you can say this is not a function. So that was sufficient to say not a function. But if you look at 4 and 4, again, that's producing different outputs. So that's another reason, only one reason all you need. No, it's not a function. Okay, determine whether the graph represents y as a function of x. Now we gave you graph. Could be equation, but graph is available, very simple. You just do vertical line test. You put vertical line anywhere you like and check it. Does it pass graph more than one point anywhere you put? No, it only passes once everywhere. So we say, yes, it is a function. Okay, determine whether x equal to 3y squared represent y as a function of x. Okay, so what if this is a question? If you have a graph here available, then it's a simple question. The graph is there, you know it's not gonna pass a vertical line test. Excuse me. Right away you can say, no, it's not a function. But what if there was no graph available to you and you don't have graphing calculator? You don't know how to graph this. What are you gonna do? So that there's algebraic way you approach this. Yes function, no function. How? So x equal to 3y squared, you are solving for y. So divide by 3 both sides. Y squared equal to x over 3. You have to get rid of this square. So take a square root both sides. So be very careful. When you take a square root both sides, you have to carry plus minus. Many students forget minus here and make a mistake. So let me give a little explanation on that. If I say x squared equal to 9, if I ask you what's the value of x, many students answer as a 3, and they lose points. What's wrong with the 3? When someone says, well, 3 squared equal to 9, what's wrong with my answer? Well, there are more than one answer. It is actually plus minus 3. When you take a square root on both sides, your answer is supposed to be x equal to plus minus 3. Why? Because minus 3 square, parenthesis square, also creates 9. 3 square equal to 9, that most of you know. but don't forget this. So for that reason, you create plus minus when you take a square root on both sides. Okay, why does that matter? So that creates interesting thing here. Whenever you plug in x value as a certain value here, you have two different y value created here. So if you don't see that, what if I plug in x equal to 3? Let's say I just plug in x equal to 3. Why 3? Someone might say, well, the denominator is 3. I don't want to deal with the fraction. What if x becomes 3? Then plus minus square root of 3 over 3 equal to y. 3 over 3 is 1. Square root of 1 equal to y. So basically this becomes a plus minus 1 equal to y. I have x equal to 3 as a 1 input, creates plus 1 or minus 1 as an output. That's a split. One value of input of x creates two different outputs. So that's not a function. Why? Because y equal to plus minus, then you know it's busted. Okay. So this is the question here. If f of x equal to this, find this. So let me demonstrate this with a color pen here. So if I say if f of x equal to if f of x equal to x squared equal to minus 2x minus 8, that's condition provided. What the question is asking you to do is f of something. So something, you should be able to set it up like this. So f of something is equal to parentheses square minus 2 parentheses minus 8. So this part is very important. I want to emphasize. Whatever that is as a parenthesis, wherever x appears on the original function definition, you're just replacing x with a parenthesis. And it so happened to be what this question is asking is f of 2a minus 1. So you get 2a minus 1, 2a minus 1. So setting is good. What do you do from here? Just simplify. So square, parenthesis square, basically it's asking you to do 2a minus 1 parenthesis, multiply that twice. And I'm going to just distribute this minus 2 times 2a minus 4a minus 2 times minus 1 plus 2 minus 8. From here, you will have to FOIL. You will have to multiply that, multiply that, multiply that, multiply that. Or if you remember the formula from here, a minus b squared formula equal to a squared minus 2ab plus b squared. That's even better. You can use that formula. If you don't remember this formula, you just FOIL it here. So it should be what? 4a squared minus 2a plus 1. Now this is minus 4a plus 2 minus 8. Now combining like term. 4a squared is a 4a squared. Now a minus 2 minus 4 is minus 8a. Then what? Plus 1 plus 2 minus 8, that's a 3 minus 8, which is what? Minus 5. Final answer. Okay, I will continue on second part of the video.